Hello, and welcome to a little video about target 8C. Let's get started. Alright, so number one, what we're trying to do here is make these triangles congruent by SAS. So one thing that we're already given is that angle M and angle T are congruent, which means we have the angle of SAS. When we have SAS, we want to make sure it's a side angle side sandwich. So what we can do is make this side congruent to this side and this side congruent to that side. And there we have SAS. Let's write it down. We have ST congruent to ML, and we have RT congruent to KM. All right. Number two, which congruence statement can make these two triangles congruent by ASA? Now we are already given a side. It's this side right here, BC and FE, which means we need two angles. So right off the bat in number two, I can cross A and B off because they only give us sides. Now what I need here is for, let's say, angle B to be congruent to either F or E. So let's see. Both C and D have B congruent to E. Okay. Then we need angle C to be congruent to F to form that ASA sandwich. So let's see which option has that. There it is. C is congruent to F. Number three, same idea. Let's make these triangles congruent by SAS. We already have A for our angle in the middle. That means we need two sides. We need this side and this side to be congruent. Maybe we need to flop them around, but we need two sides around that angle. So that's going to help. I'm going to cross off C and D. Those are both angles. So I need AB congruent to either ED or EF. Let's see. Okay, so it's congruent to ED in both of them, which means we need BC congruent to EF or FE. There it is, option B. Let's do the same thing for number four. Let's make these triangles congruent by SSS. I don't know which S this represents. Probably the first one because it has one tick mark. And that's this side. We need two more sides so that I can cross off C and D. Those are angles. We have AB congruent to ED in both of them. So that means we'll need AC congruent to FD. So let's see, AC, FD. There it is, number 4A. All right, number 5. We need to make these triangles congruent by SAS. We are given the angle already right here, which means we need two more sides. We need these sides, and then to form a sandwich, we're going to use the reflexive property right there. Let's name these lines. We have DT is congruent to ST, and then reflexive property UT is congruent to UT. Let's make these triangles congruent by ASA in number 6. We are given AB is congruent to DC, so that's a side. Let's mark that because that's not marked. AB and DC. Okay. To make an angle side angle sandwich, we're going to need an angle right here. And then we're going to be able to use the reflexive property right there. Okay. So for our angle, we need BAD congruent to CDA. And for that side, reflexive property, AD is congruent to AD. All right. Something else that we need to look at in order to continue these proofs are perpendicular bisectors. Perpendicular bisectors are lines that form a 90-degree angle and split something in half. So take a look at this triangle. We have LN. It's perpendicular bisector of MK. That means it forms two right angles, right here and right here. We have angles MNL and angles KNL. It also forms two congruent segments, cuts this line in half. We have MN and KN. Suppose CS is a perpendicular bisector of AE. I'm going to draw that right away. It gives us right angles and cuts a line in half. So our two congruent segments become AS and ES, and our two congruent angles are angles CSA and angles CSE. All right, let's suppose IO is a perpendicular bisector of CS. Let's see if we can make these triangles or prove these triangles to be congruent. All right, so perpendicular bisector means 90-degree angles and congruent sides. What else can I label here? Well, I can label the perpendicular bisector itself as a side that both of these triangles share, and we end up with side, angle, side. Wonderful. Our congruent statements are that CO is congruent to OS, and we know that because of the bisector. We know that IOC is congruent to IOS because of the perpendicular bisector. And lastly, IO is congruent to IO because of the reflexive property. All right, let's take a look at number 3. For the following figure, Tim determines that sides PN and CB are congruent. Let's mark it. He also measures that angle C and angle P are congruent. Let's mark that. Angle C and angle P. He concludes that they are congruent by ASA. Is that enough information? Is Steve correct? No, I would say no, not enough. We only have one side, one angle, and it's just not enough information. Because of the diagonal line of PM, we don't know if it's SAS. We don't know yet how to measure this diagonal distance. All right, number 4, let's see what Kevin thinks here. Kevin determines that EK and AC are congruent. Let's mark it. He also measures angle K and angle C, and they're congruent. Finally, he measures DK and CB and finds that they are congruent. He concludes that it's SAS. Is he right? Yes. He gives us side. The first side is going to be the EK and AC. Then he gives us the angle, K and C. And then he gives us one other side to create a sandwich of DK and CB. So Kevin, in this case, is correct. That's it for Target 8C. If you have any questions, make sure to ask myself or your teachers. Otherwise, have a wonderful rest of your day. Bye!